With 5,000 to 7,000 human languages spoken in the world today, researchers have wondered whether the brain has a single system for producing and understanding any language in its various forms. When language is not understood, however, what are the causes and mechanisms in the brain that are being impacted? Processing language in the brain is the topic of discussion in this presentation. I am J.D. Lovell, Psych 602, Dr. Herzog. Neurolinguistics is the study of how language is represented in the brain. That is, how and where our brains store our knowledge of the language or languages that we speak, understand, read, and write, what happens in our brains as we acquire that knowledge, and what happens as we use it in our everyday lives. Specifically, nerves, chemicals, and electrical processing are explored and studied regarding language. Psycholinguistics is the study of the psychological underpinnings of language. It focuses on acquisition, storage, comprehension, and production of language. Certain cognitive functions can be localized more specifically in one hemisphere of the brain over the other. This is known as brain lateralization. Language is one such function that is highly localized in the left hemisphere of the brain. What are the specific brain language areas? The first one we're going to look at is Broca's area. It is responsible for the motor functions that allow us to formulate syllables with our mouths in order to produce speech. If this area is damaged, then impairment in syllable functioning would result without affecting an individual's ability to understand language. The second area is Wernicke's area. This is responsible for the understanding of language. If this area is damaged, an individual can still vocalize, but complete nonsense is spoken. The third area is the motor cortex, which is responsible for controlling movement of the muscles. Specifically, in this case, are the muscles that are used for speech production to take place. The fourth area is the arcuate fasciculus, which is a bundle of nerve fibers that connect Wernicke's and Broca's areas. This illustration shows Wernicke's model of speech recognition. The Wernicke's area and A1 area are marked on a brain at the center. A flowchart below reads from left to right as follows. A spoken word takes place. A1 receives it. Wernicke's area contains sound images of those words, and then comprehension of that word is heard. This illustration shows the following parts labeled in the brain. The Broca's area, which contains motor programs for speech. The Wernicke's area contains sound images of words. The arcuate fasciculus, which connects the Wernicke's and Broca's areas. The motor area for the face, and the cranial nerves, which transfer the information. So a flowchart below reads from left to right as follows. Thought takes place. Then from there, Wernicke's area is stimulated. The Broca's area stores the motor programs for speaking the words. This is transferred from there to the facial area of the motor cortex, which stimulates cranial nerves and allows for speaking to take place. This slide shows the location of the motor speech, writing, auditory speech, and visual speech areas located on the brain, as well as provide some information regarding the label for the damage or lesion that could take place. Aphasias are the inability to perceive, process, comprehend, or produce language due to physical damage to the brain. It can impact a person's speech as well as the way they write and understand both spoken and written language. An example would be the person who suffers a stroke. Those effects can range from mild to severe reduction in their ability to use language. The following are language disorders that result from damage to the brain or lesions. Broca's aphasia is characterized by a substantially reduced amount of speech, distorted articulation that is slow. This is a form of expressive aphasia. There's no issue understanding speech, but they struggle to form complete sentences. They still have awareness, so this is a language production challenge. Whereas Wernicke's aphasia is a type of language disorder that results in auditory comprehension. So this is a language comprehension challenge. It's a form of receptive aphasia, and there's difficulty, obviously, understanding speech. An example would be when a person is asked to repeat the word glass. They might say window or something that is in common with glass. Conduction aphasia or associative aphasia results from damage to the arcuate fasciculus, resulting in the inability to repeat words or phrases even though both expression and comprehension remain intact. Besides the three aphasias that were described earlier, this particular slide shows 5 more, and the aphasias are described from fluency, comprehension, repetition, naming, and even the lesion localization that each of them affects. Lero Borotsky, an associate professor of cognitive science at the University of California, San Diego, specializes in the relationship between language, the brain, and a person's perception of the world. She gave a TED Talk in 2017 regarding how greatly the language we use impacts our understanding of the world. She stated, "The beauty of linguistic diversity is that it reveals to us just how ingenious and how flexible the human mind is. Human minds have invented not one cognitive universe, but 7,000. There are 7,000 languages spoken around the world, and we can create many more. Languages are living things, things that we can hone and change to suit our needs. Therefore, language holds such power over our minds, decision-making processes, and our lives. As we are challenged to build new dendrites from learning about language processing, may we also be encouraged today to consider how we might use language to positively shape the way we think about ourselves and the world around us." Here are my references.